Welcome to Comparing Real Numbers. So in previous videos we discussed what rational and irrational meant, and real numbers are simply all rational and irrational numbers. So some examples of rational numbers include integers, fractions, and certain types of decimals, right? We have decimals that are repeating and decimals that are terminating. So those are all rational and irrational, or those are all rational numbers. And then irrational numbers include numbers that are non-repeating, non-terminating decimals. But we don't usually write them as a decimal that's going on and on forever. Okay? Now, when we are talking about real numbers, there is such a thing as imaginary numbers. You will discuss that either later this year or in another course. They have to do with graphing, and they come up a lot with quadratics. However, for the purposes of this course, all you really need to recognize is that real numbers include all rational and irrational numbers. And today in this lesson, we are going to learn how to order them in least to greatest, or just compare them to see which one is larger. One example of an irrational number is the square root of 2. Now, 2, the square root of 2, is between two numbers, right? We can estimate this, but we cannot get an exact answer. Square root of 2 is between the square root of 1, which is 1, and the square root of 4, which is 2. So the square root of 2 is between 1 and 2. If I narrow it down, I should get that it is approximately 1.4, maybe closer to 1.5. Both of these are decent approximations. But the actual full number is a repeating decimal that will go on and 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 on forever and ever and ever and ever. Okay? Another example of an irrational number would be pi. Okay? This is a Greek letter pi. We spell it P-I, and we approximate it at 3.14. Now, if you really want to get into it, you can list a bunch of digits of pi, and when we do Celebration of Math later this year, you can go for it and tell me the first 100 to 1,000 digits of pi as part of your project. That's fine. But for the purposes of what we're going to work with, 3.14 will suffice, and that will get us what we need. There are some other examples of irrational numbers. For example, the letter E does represent an irrational number. It's approximately 2.8, I believe, or 2.817 or 2.8717. So we are dealing with an irrational number is often represented by either a square root that is not a perfect square, like 2, 3, 5, 7, etc. Pi, a letter in Greek to represent that, or even a letter in English, that E. But those are all very special circumstances, and that's why you might see them pop up on your calculator, okay? So how do I actually compare them? Well, as I compare any rational or irrational number with each other, I am going to compare them by putting them in the same format. Now, 4/7 is greater than the square root of 19. We're trying to decide if this is true. First things first, 4/7. I can turn this into a decimal. I can also turn this into an approximated decimal, the square root of 19. So I'm going to show both. 4/7. Remember when we complete turning a fraction into a decimal, a fraction bar is the same thing as division. So I'm going to just divide. And we always put the top, the numerator, inside, and the denominator goes outside. Now 7 is bigger than 4, so this should be a number that ends up being smaller than 0, or smaller than 1, I apologize. 7 into 40, however, is equal to approximately 7 times 5, which is going to give me 35. Right, 7 times 5 here. And 40 minus 35 gives me 5, but I'm not done yet, so I'm going to keep going just for a moment here. I'm going to have a repeating decimal, I believe, so we'll take a look. How many times does 7 go into 50? Well, that goes into 57 times, so I have 49. I can keep going here. And I can go pretty long, actually. But this will end up being a repeating decimal eventually. Okay? So we end up with approximately 0.571 and so on and so forth. Okay? I'll put a dot, dot, dot there. To compare these, I am going to look and see what is the square root of 19 approximately. Well, to compare, I need to turn this square root of 19 also into a decimal. So I have the square root of 19. I'm going to think about what perfect squares are above and below that. Perfect square below it would be 16. Perfect square above that would be 25. Now 16 square root is 4, which means 19 square rooted is going to be between 4 to 5. Now, is 4 or 5 larger than 0 and 571 thousandths? Yes, it is. So, is this statement true? No, it is not. We would need to flip this the other way. 4 sevenths is less than the square root of 19, because the square root of 19 is between 4 and 5, and 4 over 7 is less than 1. For this next one, we have 20 over the square root of 30 is greater than 2/3. Now, at first glance, it might seem like they're equal to each other, right? We have 20 over 30 equals 2 over 3. That would simplify to exactly the same thing. But 20 over the square root of 30 is not quite the same. So I'm going to approximate that square root of 30 before I do anything else. So 20 is on top. Still have my 2/3 here. I'm going to just set that over there. Okay. Square root of 30 now is between the square root of 25 and the square root of 36. So this number should be between 5 and 6. To narrow it down a little bit more, I'm going to simplify 36 minus 25. So this is going to be my fraction form, okay? 36 minus 25 and on the denominator, and 30 minus 25 in the numerator. I end up with 5 over 11. So I get 30 is equal to 5 and 5/11. Now 20 divided by 5, even 5.5-ish, which this is, okay, because 5 over 10 would be exactly 1/2. So 5 over 11 is pretty close to 5.5. 20 divided by 5.5 is not going to give me exactly the same thing as this 2/3 here, right? What do we get when I do that? Pause the video and calculate your 5/11, 5 and 5/11, and 20 divided by 5 and 5/11. So 5 divided by 11 is exactly 0.45, okay? So 20 divided by 5.45 gives us about 3.7, and that is indeed larger than 2 over 3, which is smaller than 1. For this last one, go ahead and pause your video, give it a shot, and check in with Mrs. Jackson before you continue on to the rest of the lesson. Good luck.